Hello, this is Toby Barris for dmanswers.com. Today I'd like to revisit some machine data that I talked about on October 6th, 2013. That day I talked about predictive quality control and how you could use, in the data mining tab, you could use the feature selection to be able to predict which input factors were meaningful for the output. And that way you could give some clues to what to investigate if something was going wrong. Notice there is this predictor screening though, is another option. And so what I'd like to do is go back to that machine data and use the predictor screening with that. So I just choose the output as the quality score that I mentioned during that day. I'm not going to explain the data set. If you'd like to get a review of that, just go back to that blog on October 6th. For the categorical predictors, remember the batch is just an ID, so we won't include that. So we'll just use sublot 1 up to machine 8 as the categorical predictors for the quality score. We don't need to necessarily enter anything else. We'll just keep the defaults. So let's go ahead and say OK. And it will find the best predictors. This methodology is a little bit slower to get an answer, and so that might be one of the reasons why you'd want to still continue to use the feature selection over predictive screening. But nonetheless, we'll give it a chance to see what it comes up with, and then evaluate the results compared to what we found in the previous time that I evaluated this data. So it looks like it's going to be done, and so we'll click on the summary of the variable importance. One thing to note is that you come up with a negative F statistic and a huge R squared, which is very strange. So what I did is I went back and I took the machine data and ran it through the data health check summary. And I did review this data health check summary a while back, and I really like this. This is something new for Statistica 12 in Data Miner. And what we want to look at is the sparse data is one thing we'd like to look at. Also, we'd like to look at the redundancy. And so I've changed the redundancy so if there's a Kramer's V value is less than 0.7, that would be flagged as, or excuse me, if it's greater than 0.7, it would be flagged as being redundant. And we'll check that we would automatically remove those redundant variables. Okay, so you say okay. I'm not going to run this. I already did run it, and so what it will do is let's look at the report, and you'll see here that for the variable summary, that the ones in red are the ones that identified as redundant. And if you want to know a little bit more about how they're redundant, you can go down here to the redundancy check in the Kramer's V color map, and it will show you the correlations for categorical variables and the ones that are highly correlated. So right here you can see that machine 5 is highly correlated with the master lot. And there's essentially a very high correlation between the master lot and the sublot 1 and sublot 2, and so forth. You can continue to go over and look at the rest of these correlations. It looks like the machine 3 is highly correlated with several of the other variables. And so then this right here breaks down and shows, according to that criterion of 0.7, where the redundancies lie. And then based on this table, we have the ones that are removed. And so in actuality, it's not informative for us to include sublot 2, master lot, and so forth, any of the ones in red. So we will really, for this check, the only thing that would make sense is to do the ones that remain. So I'll go back and we'll look at the feature select or the predictor screening, and we're going to start a new one. And I'll scroll this over, and we're going to check the continuous dependent is still quality score. Category predictors are going to be sublot 1, user machine 1, machine 1, user machine 2, machine 2, user machine 3. We'll do the user machine position, sublot, user machine 4, and then machine 6. Go ahead and click OK, and again, we'll just leave the defaults, say OK, and let it find the best predictors. Just wait for a second. Click the summary variable importance, and we'll see that user machine 1 is identified as the most important variable. The statistic was 27.4, but notice that the R-square value is only 0.07. So even though this is the top one according to the F statistic, and also by the R-square value, the R-squared is very small. And so this variable is not explaining a lot of the variability in the output. So in actuality, I don't know that we would really say that any of these variables are really explanatory in the output. Now, this could be useful. I'm going to bring up the workbook from the prior blog that I did. Whoops, that's not actually, sorry, that's not the one. Excuse me. Here's the workbook from the prior blog, and you'll see here that user machine 1 was the most important variable. So it seems as though that when you use the feature selection, that it already takes care of these redundancies for you. But what is left out is the R-square value. So I'm thinking that predictor screening would definitely be a better method in this case where you have a continuous output so you can look at that R-square value. The problem is that if you're going to use predictor screening, you've got to make sure you do the data health node and get rid of any redundancies. Otherwise, you're going to get weird results like a negative F squared or F value and a very large R squared value. Okay, so thank you for listening. I hope that these tips are useful to you. I think this predictive screening is very powerful. I just had been thinking about this again and just wanted to bring up some of these issues that I had found as I was delving into some of the other possibilities of ways of doing the predictive screening. So until 2 weeks, we'll talk to you again.